Vision models are language models that can not only comprehend and output text, but they can also understand information in the form of videos and images. And what this allows us to do using these models is do things like answering questions from images or video, extracting key points of information from charts or diagrams or your financial PowerPoint slides, generating summaries or descriptions describing what an image or a video is about, which you can then use for doing things like vector retrieval in your application, all kinds of stuff. And there are already a lot of models available that do have vision capabilities, and they can actually do pretty impressive stuff already. Not even just looking at individual points of information in an image, but actually looking at different parts of an image and reasoning about them to draw some kind of conclusion, as we're going to see later in the video. So in this video, we are first of all going to cover what exactly are the different options, both in terms of proprietary models, but also some very powerful options on the open source side. And after that, we're also going to go through the steps of setting up a couple of these models. We're going to be setting up Google Gemini on Google Cloud. We're going to be using GPT-4. We're also going to be looking at the new Claude 3 family of models released by Anthropic just 2 weeks ago. And then finally, after setting up all of these models, I have prepared a small test set of images alongside some standardized questions that we're going to try and answer about those images. And then we're going to run that test set on all these different models and then finally do some comparison, see how well the different models perform compared to each other. Not just in terms of the quality of the answers, how well the models can reason about images, but also the latency, how fast the models are compared to each other. And also we're just going to look at some general difference in behavior that these models have, the differences in the style of answer that they tend to give. And what has surprised me the most, that there are actually also some pretty clear difference in terms of content policies between the models, where there are certain types of questions that some models will just straight up refuse to answer, whereas some other models will answer that same question without any problems. And so we're going to be looking at all of that in this video, so let's get into it. Before getting into the hands-on part of this video, here's first just a high-level overview of what exactly the best possible options are currently in terms of the available vision models. And so first we have Gemini from Google, available on Google Cloud, does support vision both for images and video. And although it took Google a while to make it available in the European and the UK regions of Google Cloud, it is now also available there since I think February this year, so just a few months ago. And that's important, especially if you're an enterprise user and you really care about where the model is hosted and therefore where your data is processed as well. And so that's good to know. And then of course we have the forerunner when it comes to vision, GPT-4. OpenAI introduced GPT-4 with vision back in last November. In terms of cloud hosting, that's also available on Azure since December. And that's also available in all the regions across the Americas, Europe, and Asia as well. And then the most recent addition, Claude 3, which was released just a few weeks ago in mid-March by Anthropic. And the Claude 3 is actually not just one model, but it's a family of 3 models of different performances. So you have Claude 3 Opus on the top, the most powerful, but also the most expensive and the slowest of the 3 models. And then in the middle, in mid-range, you have Sonnet. And then finally, the most lightweight, the least capable, but also the fastest and cheapest of the models is Haiku. What I find really cool is that all 3 of these models in the Claude 3 family, in fact, do support vision. And of course, the performance in doing image comprehension is gonna vary depending on which of the models you are using. I did actually find, and you're gonna see a little later in this video, that even the most least performant of the 3 models, Haiku, does have just pretty impressive vision capabilities as well. And finally, in the open source bucket, starting with the usual suspects, Llama 2 and Mistral 7B, neither of these 2 popular open source models do support vision, but don't worry, because there are actually some very good options out there. First one being Cog Agent, which is an upgraded version of a previous model, Cog VLM. And I've actually spoken to 2 different people who are actively using Cog Agent in their startups, in the products that their startups are building, in live production settings. And what they both separately told me, Cog Agent is actually, at least for their use case, really near, if not at the level of GPT-4 in terms of the vision capabilities. And then of course the fact that it's an open source model means that you don't have to worry about rate limits, which can be quite restricting with these proprietary models, especially when it comes to the vision rate limits. They tend to be quite low. But of course, if you're just running an open source model on your own compute or on cloud compute, then rate limits aren't an issue. And not only that, but using an open source vision model means that you can then fine tune the model freely to be even more performant in your particular use case. And then aside from Cog Agent, there's another one as well called Lava. And they just released the version 1.6 with 34 billion parameters in January this year. And while I haven't spoken directly to anybody yet who's been using Lava in any real production setting, just from what I've seen and read online with people's experience using this model, I do get the impression that it might be as good, if not even better, than a Cog Agent, which again is already like pretty good. So yeah, also two very strong open source options out there when it comes to vision models, and both of these models are available on Hugging Face. I'm not going to be trying out either of these models in this video, but that might well be part 2 to this video where I just focus on these two. But that's it for this overview, and now we are going to take a look at how you can actually get started using these models. So here we are going to be setting up our functions for interacting with all of these 3 different models: GPT-4-Vision, then Gemini Pro on Google Cloud, and then finally Claude 3. We're actually going to be using 2 different models from the Claude 3 family. And so we're going to be setting all of those up, starting with GPT-4, then Gemini, Claude 3. And then we're going to run the evaluations using the RAGAS evaluation framework. And we have this class defined here for doing that, which is going to run our test set consisting of these various images in our data folder here. And then we have some corresponding questions that we're going to try and answer from each image. And then finally some ground truth answers, which is just some expected correct answers that we're going to use to evaluate how close the models get with their generated answers. And then we have these few functions here for actually running the evaluation. And then finally, we're actually also going to visualize the results we get from the evals a little, so we can get this nice high-level comparison and high-level overview of how the performance between different models compares. But we'll get there at the end. So just starting here, we are first going to look at the GPT-4 model call, which is probably going to be the most familiar to you. Maybe some of you have already tried this yourself. But we're just going to initialize the OpenAI client just like normal. And here we have this helper function as well. And this is just going to encode our images from these PNG and JPEG formats into a base 64 encoding. And all that means is that it's going to take it into a string representation. And this way we can pass it as part of our model payload as part of our JSON. So that's all. We are going to be using this function a few times in the course of this notebook, so that's why we defined it here. And then for the GPT-4 function itself, it's going to take 2 arguments. First one is going to be the image path to one of these locally stored images we have, and the second one is going to be the question that we're going to want to answer from that image. And then the first line in the function is just going to do the base 64 encoding that I just described. And we are also going to start this timer here because, as well as the quality of the model responses, we are also going to compare the latency or the speed between these different models, and you're going to see there's going to be quite big differences there as well. So that's going to be interesting to us. And then the model call itself, just going to be pretty standard, just chat completions create. Most importantly, this is the model reference that we want to use, GPT-4-Vision preview. At the time of recording, I'm sure at some point they'll drop the preview tag here. But for now, this is how you refer to the vision model. And messages also, nothing too crazy here. We'll have 2 user messages as part of the list of messages. First one being just the question, a text content, and then the second one being the image. So just specifying the image format, image JPEG 64, and then our base 64 encoded image there. And then after this model call finishes, we're gonna stop the timer. And this is going to give us our latency, how long it took for the model to respond. And the model response is also going to contain the information on the token consumption. So we're also going to share that into a variable. And then, of course, the actual response content itself. And then we just return these 3 things. We return the answer, and then we return the latency and the token consumption. So we're just going to define these functions and give them a little test. On one of our images here, we have this financial projections image, which is just this dummy financial presentation slide. And we're going to ask the question of revenue projected for 2018. And more interestingly, then there's a follow-up to see for the model to answer if the company is going to be profitable in 2018. And this is quite interesting because first the model is going to need to catch this number, 4.8 million for 2018, but then it also needs to catch this break even that's been marked here for 2017. And then it needs to do a little bit of reasoning to see that if 2018 revenue is going to be higher than the break even, then that means that the company is going to be profitable. So we're going to see how well GPT-4 is going to do for this. And indeed, it took quite a while, 16 seconds to run this. You will see that these vision model interactions tend to be a little slow on average, but the answer we do get is more or less exactly what we are looking for. It catches the revenue correctly, 4.8 million, and then it also catches the break-even point on the third year, 2017, and it also then puts 1 and 1 together to infer that the company is indeed going to be profitable in 2018. So that's a good answer. And now this next part is probably going to be a bit more novel to most of you because we're going to be setting up Gemini on Google Cloud. And this involves a few more steps than just generating an API key on OpenAI, but it's not going to be too difficult, and I'm going to walk you through it now. And so the first thing that we're going to need to do is we'll need to do some configuration on Google Cloud, on the Google Cloud console. So we'll go to console.cloud.google.com. And if you haven't used it before, then you'll first need to create an account and sign up. But then once you do, then this is what your home dashboard is going to look like. And it's a big platform and has a lot of different services. So you'll first need to enable the services that you want to use. So we'll go to APIs and services, and then here, enable APIs and services. And then the service that we're going to want to enable is going to be Vertex AI. And this is just a big machine learning and AI platform as part of Google Cloud, also including these language models and other models. And then here I have already enabled the service, but here you'll see the option to enable the API. And that's going to be very straightforward. You just need to press the button and that's it. But there's also a second thing we need to do here, which is related to authorization. So actually managing access to use these various services. And we're going to do that by creating what's called a service account. If you are familiar with Azure, this would be something like a service principal or an IAM role on AWS. But on Google Cloud, this same concept, more or less, is called a service account. So on the sidebar navigation menu, we're going to go to IAM and admin and service accounts. And then here we're going to create a new service account. We'll just call it a vision model demo. And we're going to need to give it some permissions. And for this case, we're just going to give it the Vertex AI admin, which is going to allow it to use all the resources in the service. And then this last step we can skip. Then going into the service account page or details, then here we'll need to generate a new key, and we're going to do that here. Create new key in JSON format, and then that's going to download for us a JSON file of the credentials for this service principal, and we'll just move it over to our project directory. And then we're going to see this file here with the service principal or the service account credentials. Now, obviously, typically you want to be very careful about sharing this stuff, because if somebody does get access to these credentials, then they could be using your Google Cloud account and rack up quite a bill for you to pay. Now, I'm just going to delete this service principal before uploading this video, so it's not a problem, but just something for you to understand in your own case. But after we have this JSON here, then we'll need to set this file name as an environment variable in our .env file with the name Google Application Credentials. And then this is going to tell the Vertex AI library that we're going to be using in just a minute which file it's going to find the credentials for authenticating to the service. And we're also going to need the .json extension here with the file name. Save the file. And basically that's all we need. Now we are basically set for using the Gemini model. So now let's look at the actual code. So we are using the Vertex AI Python library, Python SDK, importing these few things. First, we're just going to call this init function to specify which Google Cloud project we want to use and which location we want to use. And then we're going to initialize the model with this generative model class or wrapper, with that being Gemini 1 Pro Vision. And then for the function itself, it's going to look quite similar to our previous GPT-4 function, in that we are going to take a image path and we're going to take a question. The main thing that's going to look different is the actual model interaction. but again, it's going to be quite straightforward. Mainly, instead of this messages object that you're used to seeing with the OpenAI API, with Vertex AI, the content to be passed to the model is actually handled with this path object or path class. But just like before, we're going to have two paths that we're going to pass to the model. One is going to be a path from the image, and here we don't need to do the base 64 encoding. The Vertex AI library is going to do that part for us here. And then the other part is going to come from text, and that's going to be our question. And just like before, we're going to run a timer here to get the latency for the model response. And then the response itself we get by calling the generative model with the dot generate content with the list of paths that we want to pass. So that's the question part and the image part. And after that's finished responding, then we stop our timer, get the latency. And this response again is going to contain the information for the total token count. So we save that into our token usage variable. And then we're going to try and return these three same things as before: the response, the latency, the tokens, except if something goes wrong, we're going to catch exceptions here. And that's basically our Gemini function. And again, we are going to test it with this one question using a different image this time. So this is going to be a diagram explaining a topic modeling concept in machine learning called LDA, which is used for identifying or classifying which topics are found in a given text document. And we're going to ask the model if it can recognize from that image what concept it's about. And so we're going to call Gemini with that image and that question. Indeed, it gets the method right. It's a topic modeling method, but more specifically, it's a topic modeling method called LDA. And so again, that's a pretty good answer. What you will notice here, and especially later on when we run our whole test set, that Gemini is a lot faster, and part of that reason is probably that the responses it gives tend to be a lot more concise, whereas GPT-4 as well as Claude 3 tend to be a lot more verbose and detailed in their response, which is not necessarily a bad thing. It just sort of depends on your use case. Do you prefer the more concise, to the point answers, or do you want more detail? But that's just one of the interesting differences that I've seen between these different models when running this kind of experimentation. And then finally, we just have our setup for Claude. And this is going to look a lot more like OpenAI, more OpenAI than Gemini in terms of simplicity, because all you're going to need is just your Anthropic API key from the Anthropic console, and you just need to make sure that you also have that in your environment variables with the Anthropic API key. And again, be careful about sharing your API keys. I'm just going to delete this key before I release this video, so that's not going to be a problem. But once you have that, then you can just initialize the client just like you would do with OpenAI, and even the client syntax is going to look very similar to OpenAI. So here again, we have our function, which is going to take an image path. It's going to take the question related to that image. But here, because the Claude 3 family, like I mentioned earlier, does consist of these three different models, all of which have vision capabilities, we are also going to specify this model argument. And by default, we're going to use the Opus, the most powerful model, but we're also going to leave us the option to use, we're also going to be trying Haiku later on, which is the most lightweight and the most fast model. So we're going to use this function for evaluating both Opus, but also Haiku. So that's why we are also going to specify this model argument so that we can choose which model to use. And otherwise, here again, we'll do the base 64 encoding of our images. And here we'll also need to specify whether the image format is going to be JPEG or PNG. So we're going to take that from the image path, because some of our images here are in PNG format, while others are JPEGs. And we'll need to specify in our Anthropic call which format it is for a given image. And then the rest is going to be very similar. Again, starting our timer for the latency, and then running the client. And then for the Anthropic client, instead of chat completions, it's just going to be .messages.create, with model being the model that we have defined here, maximum output tokens, and then the messages object, just like you would have with OpenAI. And just like with OpenAI, you'll have two components to the message content. You have one message with the image content in base 64, but also specifying the media type. And this is where we're going to put our image type from up here, either JPEG or PNG, and then the image data itself in base 64. And then the second part, the second message, is just going to be the question. And after the response, we get the latency, we get the actual message or the response contents, and then we also get the tokens. And just like before, we return these three objects as a list: message, latency, and tokens. So define that function, and we're going to try it again on the previous LDA topic modeling image, just like we did with Gemini. And we'll try it with Opus, the default model, the most powerful one. So we'll not specify the model parameter and see how that works. And it's taking even a bit longer than GPT-4. And as I mentioned, the answer is correct. We have the LDA recognized here, but it's also very detailed about the diagram more generally, really describing the process of running, of doing LDA. So for better or worse, you have a lot more detail in the answer, but it's a good answer nonetheless. But now we're also gonna try and see it with the most lightweight model, the Haiku model. And I think this answer actually really highlights well the difference here, which is that the response is a lot faster. Haiku is known to be a very, very fast model. I think it's super impressive that we have a vision model that can offer this kind of speed, but we can also see that the answer quality itself isn't quite as good. It does recognize that the image, the diagram, is about topic modeling, but I think it fails to identify the exact technique, which is LDA, anywhere here. So we do have this interesting trade-off here in terms of latency versus the strength or quality of the answer. But overall, I think it's really cool that we have this selection of models in the Claude 3 family, that overall, even from Haiku to Opus and Sonnet in between, they are all really good models. And then you can just choose how much power you need for your particular use case, considering the trade-offs of latency and cost. So now that we have all our model interactions all set up, now we can actually move into the evaluation part. And I described this class here briefly earlier, but a few other things I didn't cover yet is that aside from our test set here, consisting of images and questions and then expected answers, we'll also define which metrics we want to evaluate for, because the RAGAS framework offers all kinds of metrics for evaluating RAG systems generally. If you're doing some form of retrieval, there are metrics to evaluate how good your retrieval is. There are metrics for evaluating how much hallucination there is in a given answer. But in our case, we aren't actually doing any retrieval. We're just doing a pretty simple Q&A. So the only metric that we are going to be evaluating for is this answer correctness metric that we import from the RAGAS metrics module. And then we have this function here that's just gonna call the correct model depending on which model we are evaluating at a given point. So these are just all the functions that we have defined so far. If we are evaluating GPT-4, then we are using the GPT-4 function, same for Gemini. And then we are gonna evaluate both Opus and Haiku from the Claude family. So then the function is going to be the same for both of these, with the only difference being that with Opus is the default model, so we don't specify the model here. But then for Haiku, we need to explicitly specify that we want to use the Haiku model instead of Opus. And then for our main entry point into running this evaluation is going to be this run evaluation function, which is just going to iterate over our test set. And for each question in the test set, it's going to call the correct model and then save the response, save the latency, save the tokens into these lists. So then by the end, we'll have, for our 9 questions in our dataset, we'll have 9 answers, 9 latencies, and 9 integers for the token usage per each answer. And out of those lists, we'll convert them into this dataset object. And the dataset is an object that's part of the Hugging Face ecosystem for working with various different types of datasets. And RAGAS also, as part of the broader machine learning ecosystem, is designed with these dataset objects in mind. So when we run this evaluate function, which then comes from RAGAS, we import it here from RAGAS import evaluate. The first argument for that evaluate function is going to be a dataset object. And then the second argument is going to be the list of metrics that we want to evaluate that dataset for. And again, like I showed before, this is just going to be this list of one metric that we're going to be concerned about, the answer correctness metric. And after we run the evaluation, we are also going to save it into a CSV, a separate CSV for each model evaluation, just to make sure that we don't have to rerun the evaluations every time we want to look at the results, because it does take quite a lot of time, a couple minutes to run all these evaluations. And so with that class defined, then we're just gonna create an instance of that class. And for each of the models that we want to evaluate, we're gonna call the run evaluation function with that model, and then it's gonna run and save our evaluation results for all of these 4 models. But yeah, this is gonna take a while, so I'm just gonna skip ahead. So now that's finished running. I actually ran into an error there at first. I had to introduce a little delay to the Claude evaluations because, as it turns out, the rate limits for the Claude 3 models on the free tier is only 5 requests per minute. So we're crossing that running our 9 evaluations, so I had to add some delay there. But now all our evaluations are finished. All the results here are stored in these CSV files. And now we can take a look. We can just read the CSVs like so in a data frame where we have the question, the expected answer, the model generated answer, as well as the latencies, token usage, and then the RAGAS given score for how correct the answer is from 0 to 1. Now I also mentioned visualizing these results. So what I've also done here is I've created this very simple Streamlit dashboard that we can use to show all these results side by side and get this nice high level overview. So we're just gonna run that now from our notebook, run our dashboard for a nice view like this. We have just the averages for all the values that we care about, the average correctness, the average token consumption, and average latency for all the models. But here we can then also just examine the per question level details as well. And so of course, while this is still a pretty small test set that we are using, 9 questions, not representative for all cases, certainly. From what we can still see here is that Gemini is definitely crushing it compared to the other models, not just on the answer correctness, which is very high, but then also the latency is really good and the token consumption is also very low, again being related to the conciseness of answers that Gemini tends to give. And then we have Opus coming in second on the answer correctness, but being quite slow with a quite high token consumption. And I'm actually quite surprised to see Haiku doing so well as well. We have not the worst answer correctness while having this really good latency for a vision model. And Haiku, the most lightweight and least powerful model of the 3 series, is actually even outperforming a GPT-4 here. And yeah, that I find quite surprising. But looking at the details here, we can actually identify a couple of very clear reasons why the scores look the way they do, why Gemini is outperforming the others so strongly. And that's related to a couple of these questions. One of them being this image, which is a tooltip from the Lex Fridman show, showing Lex on the left side and Jan LeCun, the chief AI scientist of Meta, on the right side. The question we are asking for this image is, who are the 2 famous people in this image? And while Gemini is not getting it quite right, it's identifying Lex in the image, but mistaking Jan for Elon Musk, which is kind of funny. But nonetheless, it's trying to answer the question. And the same goes for this one, where we have a license plate of a car that we are trying to identify. It again doesn't get it quite right, but it gets very close. And we also have this other image with various billboards, and we are asking it to get us the text in the longest billboard in the image. So it's quite a challenging task. But Gemini is getting it correctly. The longest billboard in the image reads Madame Tussauds, and I'm actually going to show you the image, this one. And yeah, here we have this long billboard saying Madame Tussauds. Now, why this is important is that if we look at these 3 questions for the other models, for Claude, Opus, when looking at the image with Lex and Jan, while it does give us some information about the image generally, it tells us here that it's not able to identify specific individuals shown. And we see the same thing with Haiku, even a bit more explicitly, where it tells us that it can only describe what it sees in the image without naming or identifying the people. And this is even more dramatic with GPT-4, where it's not even trying to give us any information about the image. Instead, it simply tells us that it can't provide the identities or names of real people, including famous individuals. And it even has the same issue with the license plate, for the same reason it can't help with identifying or making statements about license plates. And what surprised me the most of all is that it also has a guardrail against providing text from images that contain advertisements. And so this is clearly related to differences in content policy, what the models are forbidden from doing. And it's, quite surprising, even a little annoying. I'm not sure how reasonable it is to have anti-advertisement guardrail in GPT-4. But nonetheless, it is what it is. It's certainly good for Gemini in this comparison, where it really doesn't have any issues with any of these images. And so, of course, again, this is still a very limited test set and might not reflect for whatever you are possibly wanting to do with these vision models. It might just be that for your use case, GPT-4 would perform the best, and maybe these kinds of content policies, for example, wouldn't be an issue for you. But nonetheless, I think this is a very good example of the kinds of difference in behavior that you can find when doing this kind of comparison between different models. So that's it for this video. I hope you've enjoyed, gotten some value out of it, and I'll see you on the next one.